Good evening, everybody, and welcome to the University of Queensland's BrisScience public lecture series, where we aim to bring not just the best scientists, but also the best communicators to share their research and their passion with Brisbane. I'm your host for this evening, Joel Gilmore, and I'd like to start by respectfully acknowledging the traditional owners of the land on which we're meeting tonight, and to pay my respect to elders both past and present. I'd also like to do a shout out to The Edge, where we're hosted here tonight, the fantastic tech team up the back who always make these evenings run so smoothly. No pressure for tonight. It is fantastic to be here for another year, and do check out outside all the other great things The Edge has going on, great workshops, a makerspace downstairs you can check out. So I do encourage you to get involved with that aspect of science as well. Couple little bits of housekeeping before we start. If you could put your mobile phones on silent, that would be fantastic. But keep them Wi-Fi connected. There is free Wi-Fi here. We will be taking questions after our talk over Twitter. And so you can use the hashtag BrisScience, and we will go through as many of those as we can. We'll also be taking questions via those little question slips from the table outside, or anything you want to write those questions down on is totally fine. And we'll come around and collect some of those at the end and get through as many as we can. Finally, we do have some food and drink available afterwards, so we'd love for you to hang around, join us outside to keep that chat going, and also have a chat to our speakers, some one-on-one discussions, hit him up for postgrad work, whatever it is that you're looking for tonight. Okay, I think that's great to get started. So tonight I'm very excited to be introducing Professor Brian Lovell, who is the Director of the Advanced Surveillance Group from the School of Information Technology and Electrical Engineering at the University of Queensland. And Professor Lovell has a long history in pattern recognition science, including being President of the International Association of Pattern Recognition. So he's definitely got the credentials. Tonight, he is going to share some of the very exciting and intriguing science behind facial recognition technologies and its potential to streamline our lives and even increase productivity. I know you're going to have lots of questions afterwards, so make sure you keep those notes ready. But for now, please put your hands together for our speaker tonight, Professor Brian Lovell.
That's me, 100%. Could we turn up the program audio from the computer, please? Thank you. So this is just a system we whipped up the other day, and you can see it's face recognition. This is for CCTV cameras and so on, designed for wide area deployment, and this is using an artificial intelligence engine for recognition. I'll say a little bit more about that. It's got, the program audio works, if I hide my face for about 20 seconds, you should see the alert disappear on the left. The box goes off my head, and then it should be primed to give another alert. So normally it gives a spoken alert, but for some reason this time it didn't do that, but it could be something to do with the audio. So.
Welcome everyone. I am Professor Brian Lovell.
That's the spoken alert. Okay, so that's the demo. It's always good to get the demo out of the way at the beginning. So then you can sort of recover from that. If you look at that sort of software, this is the sort of thing you can do. This is face in the crowd recognition. Way back in 2011, we won the award for Best CCTV System of 2011 for face in the crowd recognition. And that's an example of what you can do with, recognizing multiple people and labeling them as they move down a corridor, for example, and across multiple cameras. Then we've also done work on mobile biometrics. You can see here, this is the first time I got this going. I'm actually holding a set of augmented reality glasses, and this is the view from the glasses. So it's got John Lennon being recognized, putting an alert on this person saying, "Arrest John Lennon." Okay, so this is typical security implications, and you look at somebody, it tells you who they are and what you should do when you see them. So I've got a friend of mine, Danny. When I got this working, I walked straight into his office. We were wearing the glasses, so he's given me a quizzical look, and it's come up and recognised Danny and says he's a researcher and no action required. And so I look at him again, and it's basically done the same thing, so I know who that is, and I don't have to do anything. Then I went down to see my postgrad students. This is just outside my office, my old office. And I came in to see my postgrad student, Siki. Here she is. She's also a researcher, so when I look at her, pops up, and they hadn't seen this before, and it comes up and says she's a researcher, you don't need to do anything. And we've also got a visitor from China, Dayan, and I look at him and it says unknown person because I haven't enrolled him in the database. He's not in the database, so we take no action. Okay, I'm seeing Siki again, and Dayan again, just to check that you get the same answer. And then I see Danny trying to sneak off to get the bus, and I catch him as this is all live. I catch him and it says, okay, I don't have to do anything. So that's the sort of thing you can do. So we've done some pretty interesting projects, like during the Olympics in Rio, we connected up 3 systems in the UK, Australia and Rio de Janeiro across the internet, and we're able to see when people walked into the office in Rio and in Sao Paulo actually, and in a shopping centre. So that's obvious application for that. I'm not going to talk about that. That was the introduction. I'm going to talk about all these other cool things you can do with facial recognition. So facial recognition for border security and banking is becoming mainstream now. You know, when you go through the Australian border, you don't just get checked coming, you get checked going. I find it really good because the queues are really small. And this is a lot of what it's about. You know, when we didn't have facial recognition, you spend half an hour waiting to get through customs control. Now you can just breeze through when you exit, and you don't even have to fill in the cards. I know the guy who got customs to drop the exit cards, and it was a big battle so that people didn't have to fill in any forms. So that's good convenience too. What's the point of having facial? Yeah, I know, he's a hero, absolute hero. So I'm going to focus on these other aspects of ubiquitous face recognition applied in social and consumer applications. So forget about safety, security. Let's look at other things, okay, and using the same technology. I'm here to focus on the sheer convenience of face recognition compared to other forms of identification. You know, case in point, anyone with an iPhone 10 or above, you look at the screen and it's unlocked. You don't have to type in a 4-digit PIN. I pick up my wife's iPhone 6, say, oh, how do you, oh, God. Okay, you're into the phone. And I used to think that was really good, that you only had to type a number or use a fingerprint. Now, if it doesn't have face, I just think, oh, gee, I have to push my finger on the button. It's not a lot of work, you know. So, I'm live. Am I still? Yeah, good. Okay, just dropped out for a sec. So look at sheer convenience. This really inspired me. There was a talk from Angela Sasse. Angela Sasse is from University College London, and she's an expert in human-computer interaction. And she's done a number of studies for large government agencies in the banking sector, and with these studies of time and motion, she's worked out that each of us spends 3 working weeks of the year identifying ourselves. You think about how much time you spend doing this. Every time you ring a bank, they say, please give us your name, please give us your favourite colour, what's the name of your first dog? And it's really important when you have a child and you give them a dog to make sure they give it a really good name, because they're going to be quoting that dog's name for the rest of their life. Okay. So that's 3 working weeks. How many working weeks do we have? Well, 52, take away 4, 48, and you're losing 3 of the remaining working weeks just telling people who you are. Because every time you log in, every time you use telephone banking, every single time you're having to identify yourself. And if any of you have had the horror of looking after an estate, for wills and things, identification is an absolute nightmare. Nobody will talk to you. They won't even tell you if there's a bank account unless you identify yourself. So you have to send all these documents with multiple signatures through the mail, and they won't talk to you for a month until they've received every single document certified by JP. Okay? That's a huge amount of time. So every time you reset your password, that's time lost. Okay, you forget your password, ask for a new one. Yeah. my wife is now carrying around a set of passwords in a tiny form. She's got in her system, she's in a hospital, I won't say which. All the systems have different passwords and they all expire and they change every month. So she has to carry around a list of about 40 passwords, which completely defeats the purpose of passwords because she has to carry them in a list that's sitting around that everyone can read, you know. But nobody can cope with that. So if we could reduce the workload of identification to, say, 2 weeks, let's not be greedy, we could boost the whole world's productivity by about 2%. So this is the sort of thing that I think is really interesting. Imagine how much that's worth for society. And just how nice it would be not to sit there identifying yourself on a telephone line all the time. So this leads us to several new and quite interesting research problems that we're looking at. So this is an outline of the talk. We're going to talk about conventional cooperative face recognition. This is like airport systems and so on, which, you know, hopefully most of us have used at some point. Talk a little bit about face recognition technology, and that's won't get in very deep there, but I'll tell you the answer, because I know the answer is always the same these days. It's just the slightly different twists on artificial intelligence. I'll talk about something you can download for yourself, which is Social Recall, which is an app for people with Prosopagnosia, and I'll tell you what that is. A conference app for scientific conferences, which is close to my heart. Augmented reality facial recognition. A medical project, which is using facial recognition to detect genetic disorders in children. Another project, which is to recognise faces of animals. So can you identify all your animals? Are you as good as an animal at recognising other animals? That's an interesting question. I think I've got that already, AR face recognition. And there's one other thing that just came to me yesterday, which is a new project on neonatal intensive. My wife's a neonatal intensive care specialist, and I found that an application in neonates for face recognition. So let's move on. So this is what we call cooperative facial recognition, or facial verification. It's a special type of recognition because all it does is match you against a purported identity, which is the identity on your passport. Okay? So why that's really cool technology, or one of the reasons, is it's an Australian technology. Australia was the first in the world to get this right. Okay, and it took a long time. Started just after 9/11. First rollout in Brisbane, was in 2007. And Brisbane was also the first place to roll out face recognition on exit. So Australia's had a lot of input there. Unfortunately, the underlying technologies was from Germany, now it's from Spain. Okay, but the one thing's the technology, the other thing's to actually make it do something useful. And we were the first to have it useful. And now New Zealand, Manchester, UK, etc. have all copied the systems from Australia. So these are smart gates. Now, how do they work? They are very high resolution, so you've got very high quality cameras there. There's multiple cameras or a single camera that moves up and down to account for the height of different people. So the reason they move is so that they can be at eye level, so they control the angle of view. You control the lighting through the fluorescent lighting on the sides. You tell the person not to smile and take their glasses off. You have little footprints on the ground, so they stand there and they don't move, and then about 80% of the time it will get it right. 20% of the time you have to go and use a human. Okay, so that's still good. And they're getting better all the time. So that's a cooperative face recognition system in the sense the person's doing everything they possibly can to get through the automatic gate so they don't have to wait in the queue to go by the other path. And there's many commercial solutions in this space, and they're fully tested by NIST, which is National Institute of Standards and Technology in the US. So most of these have gone through extensive testing to say that they are fit for purpose. Okay, so the question is, you've got a face in the passport and a face that's presented at the gate, and the question is, are these the same person? Okay, and they've found that this works pretty well over a space of about 10 years for most people. That's why our passports last for 10 years. For children, they only last 5 years because their faces change faster. Okay. So it's primarily used for passenger facilitation. It's not anything much to do with security. It's to allow people to get through the gates faster. Okay? It also provides fantastic overflow because when it's really, really crowded, you force more people into self-serve queue, just like at Woolworths and Coles. okay? And so it means they don't have to put more staff on for a peak period, because when you put a staff member on, you have to hire them for a shift of minimum 4 hours or 8 hours, and they're very expensive when you might only need them for half an hour when it's busy. But by having these automatic gates, you can have a smaller number of staff, and you still don't have the queues because people go through the queue, through the automatic gates. Now it's used for departures as well, so that they check you when you leave the country and make sure that you match your passport. That was after that Cooperative fellow got out of Australia on his brother's passport, and so now they want to check that when you leave that you match the passport. Okay, not interested in that. That's done. It's fantastic. It's been deployed. That's not a research problem now. That's basically a commercial problem. So what I've been looking at is live face recognition for the masses, mostly so the public can use it, that works reliably from any camera or a mobile phone. And this is now largely achieved. Okay, so it sounds like this is the same thing, but it's actually quite different. And the way I tend to explain it is to think of the problem. So if you've got a cooperative face recognition system, it's very smooth conditions, very well controlled, and you can get very high accuracy. So that's sort of up here. But what I'm wanting to do is to get right down here into CCTV surveillance, where the person's not helping you take their photograph, and they're blurred, and they're on their mobile phone, they're texting or something like that. It's much, much harder to get that reliable. And so we were working down at this end, not at the border control end. It was down in this space here. And the analogy I can give is that up here is like you're on a very good racetrack, and it's very smooth and you can go very fast, so you can have a Ferrari and it does very well. And if you had a Ferrari in the F1 and you had a Land Rover, of course this one would win all the time because it's designed, it takes advantage of the fact that it's very smooth sailing. But if you went into the Simpson Desert, for example, you probably wouldn't be so good in this vehicle. You might want one like this. But people will say, what's the difference? They've both got 4 wheels and a driving wheel. They run on petrol or diesel. They're the same thing, but they're not. Okay, so we're trying to build SUVs rather than these race engines because they're for difficult conditions. And we're also trying to get down to the human limits of recognition. So if a human can recognise, we're trying to recognise. Typically these systems need much better than human quality photos to get good performance. And it's hard when you keep reducing the size of the images, everybody eventually turns into a flesh-coloured single pixel. So as you keep reducing resolution, of course, your discrimination tends to go down. So let's look at the technology that's used today. There's no point in talking about older technologies because they just don't perform well. And so while it's really, really interesting and people spent 50 years doing this, it's dead. Okay? So all methods now that are any good are based on what's called deep learning. The governments call this artificial intelligence. Okay? So there's thousands of methods for face recognition over at least 50 years with varying degrees of accuracy, but the neural type solutions always do better. Okay? And the neural solution will always be better than anything else that's out there that's handcrafted, and so everything is neural now, and the networks look something like this. This is actually FaceNet, which is a face recognition engine that we're playing with at the moment. It's designed for face recognition, and it's very, very accurate. It's trained on 3 million faces, or more, whatever you can get hold of. What they look like, you can sometimes visualize a network like this, and they're based for images. You primarily use what's called a convolutional neural network architecture, which is designed very much for images, and it's usually running on a GPU or a graphics processing unit. And you just have all these layers and all these interconnections, and you train them for weeks perhaps, and once you've trained them, they become very accurate. So you don't really program them anymore. You just sort of have your network architecture, and then you do a training cycle, and eventually it becomes very accurate. So these ones are trained on millions of faces using high-speed computers with graphics processing units. And so if you want to do work in this area, you need very good big computers for training at least. Running the systems is actually not too bad. You can do that on probably conventional architecture, but the training can take many months, and so you need very powerful machines to speed that process up. Fortunately, at UQ, we have very powerful machines. In fact, the largest supercomputer for this purpose in the Southern Hemisphere. I got a grant with some others at the beginning of the year. It used to have 72 NVIDIA V100 GPUs. Now it's having 144, so we're doubling the size of the supercomputer because it's already overloaded with work. UQ is a presence in artificial intelligence. That's me and a whole bunch of others. It keeps going down. And we extensively use this computer for training for research problems, industrial problems, etc. So after doing this for many, many years and being really impressing myself with what we've done, I sort of realized that face recognition is a parlor trick. People look at it and say, gee whiz, isn't that cool? But that's as far as you get, because most people can recognize faces, so why do I need that? I don't need that. What would I use face recognition for? And so it's actually, you have to, it's a technology, it's not a solution. A solution is something that solves somebody's problem, and face recognition is a technology that can form part of a solution, but it doesn't generally solve much in its own right. So why do we want to recognize faces as humans? And why would you want a computer to do it for you? Well, most of us don't need that, because we can recognize faces anyway. So why would you need to use some special device to do this? So face recognition has no value to most of the public, but you can see a good example of a valuable asset is using the phones to open the phones. People think that's cool. They can just get into the phone without having to type anything one-handed, even at night. So the gee whiz is good, but let's do something that's useful. So face recognition must solve a real fundamental human need, and you have to combine face rec with something else to provide a solution to a real problem. Okay, so by itself, generally recognition doesn't help you, but it has to do something that is an alternative to other ways of doing things that's somehow better. So a good example of this, I have to admire Apple. Apple decided to use face to unlock a phone, okay, rather than using a fingerprint reader. Why was that? Well, a few things. They thought well ahead, but one of the reasons they did that is the fingerprint reader was typically on the front of the phone and took up a lot of space. It was always also very expensive, whereas the camera had to be on the front of the phone anyway, so you could take selfies. Very important. What's the fingerprint reader used for? Nothing except to authenticate yourself. So what they wanted to do is to reuse the cameras to do the authentication, and then they could get the whole screen, a much more screen real estate on the front of the phone, and save the cost of their very expensive fingerprint reader. Okay. Apple had an excellent fingerprint reader. The one reason that Apple was so successful is they didn't put a garbage fingerprint reader in like most other phone manufacturers. They put in a really expensive one that would work reliably. And you know how much a camera costs? In the front of an iPhone 10 or something? How much do you think a camera costs? Sorry? Less than that, yeah. You can buy a cable as a spare part for an iPhone, and it has the camera, it has a proximity sensor, the microphone, I think, and the earpiece for $6 on the cable. So it's cheap as cheap, and it's quite a good camera. Okay, so cameras are really cheap. Fingerprint sensors probably $30 compared to a few cents. Okay, adds up when you make 1 billion phones. So $30 billion? Yeah, that's all right. So it has to solve something useful, and so Apple made something convenient. So everyone got the idea of using face recognition. They just brought it in. They forced everyone to accept it because they didn't make the fingerprint reader on later model phones, typical Apple. And so people got used to the convenience, and then, amazing, they introduced Apple Pay. So now they've used the face recognition and they've monetized it, so they're making money out of it. Every time you use Apple Pay, they get a cut. Okay? So that's the real drive there. They've made it convenient, and they've also made paying more convenient through the Apple Pay system. So what can you do with these things? I'm an electrical engineer and a computer scientist, and there's a nice little quote here. Faraday was talking to William Gladstone, who's basically the British Chancellor of the Exchequer, which is the treasurer of the government. And he said, what's the point of this electricity rubbish? It's a stupid thing. What are you wasting your time on that for instead of, I don't know, making horse buggy whips or something like that? What's the use of electricity? And a very appropriate response from the scientist to the treasure was, he says, "Why, sir, there is every possibility that you will soon be able to tax it." So, artificial intelligence is the new electricity. We are now in year 7 of the 4th Industrial Revolution. 2012 was basically the beginning, and we're now 7 years past 2012. What happened in 2012? That was when AlexNet won the ImageNet competition. So ImageNet was a classification of images, and it was a huge database, 14 million images, 1,000 categories. And so the classification problem was to look at a picture and say what was in the picture. And if you got the correct answer, so there's 1,000 possible outcomes, if you had the correct answer in the top 5, it was said that you'd won, or that was considered correct. And ImageNet won that competition in 2012, not by a small margin, but by a massive margin. And it was based on convolutional neural networks. So that year it was the only one using convolutional neural networks, and it won by a huge margin. Next year, 2/3 of the entries were based on convolutional neural networks, and everything that wasn't a convolutional neural network was down the bottom running last. After that, everything was a convolutional neural network. So basically it took over the image classification space, and it's never looked back. Okay. And now the error rates have gone from like 30% down to about 1% on the ImageNet competition. Massive, massive reduction in errors. Okay, so let's take a look. This is an application we wrote called Social Recall. It's still on the App Store and on the Android store, so if you look it up, you can probably download it to your phones. It will recognize 5 people pretty reliably. And we'll say this was to sort of fulfill a human need. So there's Social Recall software. Because face recognition has a bit of a creepy feel to it to some people, we used a flower to represent the software. Anyone know what that flower is? Sorry? It's an American term, but you probably know it. I think it's called something different in Australia. Forget-me-not. It's forget-me-not, so you don't forget people, okay? So that's the second story. So why do you use a flower? Well, it's a forget-me-not. Oh, okay, that makes sense. Okay, so it's to remember people, and the thing is, why would you want to remember people? As because you can actually recognise your family and your wives and husbands pretty well, I'd hope. Why? Well, normal people already have good face recognition mostly. Some of us aren't so good, but mostly we're pretty good. It's quite adequate, and it's free, and why bother having a supplementary tool? And we started working at helping the blind, and what we'd do is we'd get the blind person, and they would see somebody, and then it would write on the screen in front of them what the name of the person was, but they couldn't see it because they're blind. So it didn't really help them to use the system. We had to announce it in the ear, which is still a bit inconvenient because you don't know which person is where, and it just keeps announcing names. But apparently, if you're blind, it's actually it's really quite a problem that when somebody comes into the room, you don't know who they are, and it just, you feel worried because you think yourself, somebody's in the room, and you say, who is it? What like you like to know who's around you. It's a human need, or it's your wife walks into the room and it's nice to hello darling or something like that. Instead of that, you have to sort of try to figure out who it is, and they can't. So it's a big social issue. So it's not much good for blind people, but what about face blindness? That is a peculiar type of blindness, and it's also called prosopagnosia. So about 2.5% of the population suffer from this condition, and often they're very high functioning people, so they have perfect eyesight, they just can't recognize faces. So I was working with a guy called Sandra, and he wrote a few articles, and this one's quite good. It's living in a world without faces, and talking about he's actually got prosopagnosia. So this is his version of life, what it means to not be able to recognize people, and it's socially very debilitating. And there's a lot of very famous people who have prosopagnosia. So we actually, if you look at Scientific American in January 2019, we actually got an article there published about this app for people with prosopagnosia. And it was been downloaded in many countries, mostly in the US. So this is What's interesting is that I used to, when I talked about face recognition, I sometimes used a quote from the film Casablanca. Here's looking at you, kid, sort of recognize people. And it's interesting that he actually worked on the film Casablanca. He invented the process to convert black and white films to color, and he did the color version of Casablanca. And then he moved on, and now he does 3D movies. So if you've seen Pirates of the Caribbean, he makes 3D versions of that. So there's two ways to make 3D movies. Either you use 3D cameras, or you take a 2D film and then have somebody like him come along and convert it to 3D after the event. And it's often cheaper to do the conversion than it is to actually film in 3D. So many of the 3D films are actually converted by artists. And so the depth is actually an artistic thing that's used based on computer vision. So he's on the Internet Movie Database. If you've seen the film Oblivion, he was involved in that. If you've seen, there's a lot of films. Pirates of the Caribbean is a big one. So we'll just see one of my favorite scenes from Casablanca. Get the audio off a bit? Yeah.
Hills, I'm no good at being noble, but it doesn't take much to see that the problems of three little people don't amount to a hill of beans in this crazy world. Someday you'll understand that. Now. He's looking at you, kid.
So it's rather amazing that it's one of my sort of favorite films, even if other people don't like black and white. He's the guy who did the color version of that. And people criticised the people saying, oh, you shouldn't make a color version, but what he said was interesting. He said the film had gone out of copyright and had no value, and it was badly damaged. By converting it to a color film, it actually, you could sell it because you could get the rights on it again. And to do the color conversion, he had to convert the black and white film into a pristine copy. And by releasing a color version, he actually was able to restore and keep alive the black and white version. And when they distributed it on DVD, they had both the color and the black and white version. So it actually, by converting to color, it funded the restoration of the film. So I thought that was good. So prosopagnosia, it's also known as face blindness. It's a medically recognized neurocognitive disorder. It can be extremely debilitating in social situations. An estimated 2.5% of the population, which is about 8.2 million people in the US alone, is affected. While many people with a mild case of face blindness may simply conclude they're not good with faces, in reality, they may well fall within the prosopagnosia spectrum. It's not a black and white situation, like the film. It is a grade. So some people have actually got excellent face recognition, much more than normal, and you can call them super recognizers. Then you've got sort of average face recognizers. Then you've got the people who are face blind who can't really recognize anyone much at all. Okay, so it's not binary. A number of notable people include the actor Brad Pitt, famed primatologist Jane Goodall, co-founder of Apple, Steve Wozniak, and they all have a fairly strong degree of clinical face blindness. And the social interaction and friendly banter that average people manage innately throughout the day becomes a huge challenge for those with facial blindness because they just don't know who you are. And it's just very awkward for them. So this is probably best explained by Brad Pitt. And Brad Pitt is often known as being arrogant and not a very nice person. And partly he says it's because of his face blindness. And he's gone public with this. And he said he took a year off and just went public and said, look, I don't know who the hell you are. Tell me who you are. And then people thought he was arrogant because he didn't recognize them. You've spoke to somebody for 20 minutes the night before and they just don't know the hell who you are. And then he said, look, I've got this medical condition where I don't know anyone. And then people got even more offended. Because they didn't sort of believe him, that they said you're not recognising because you're an arrogant person. He's not being recognised, so he couldn't win. And so, do you keep this silent? Do you not tell people, or do you tell people? So it's got a big social problem. So people like this could really be handy for them if they could recognise people. Once they have the name, they're fine. If you just had like a phone app that could give you the name and maybe the names of the wife and daughter of the children of the person, then they're socially fine. So the technique they usually use is they have the girlfriend or boyfriend or whatever who guides them around in social situations and introduces everyone to them and says, that's such and such a person. Then they're fine. Okay? but they don't want to have that sort of problem. It's an very interesting topic and hard to understand, but there's a film on prosopagnosia which I was excited about because I was following it, called Faces in the Crowd, and the whole basis of this film is this woman gets hit on the head after seeing a murder, and she can't recognise the murderer, so she doesn't know if anyone's around her. She doesn't know if they're the murderer, and she can't recognise her husband or anyone, and you feel how much danger she'd feel in, because the police are saying, what's the murderer look like? She doesn't know, and it could be anyone. And then the murderer starts stalking her, and she doesn't know who it is. So it's not a bad film.
Who are you? Bryce, don't you recognize us?
What you're experiencing, face blindness. Every time you look at someone's face, it's as if you've never seen them before. Even someone close to you. Even your own reflection.
It's all we found on the bridge. No bag, no phone.
You really look drop dead gorgeous tonight, Anna.
You see with me right now. Could be any goddamn one of them.
Don't you recognize me anymore?
Just another face.
So, I'm not sure if it's on Netflix or something, but it's all on the face blindness. Okay, what's another situation where normal people feel inadequate with recognising faces? And as a university lecturer, I have this problem with students. Of course, I've got 300, 600 students. They all know me, I don't know them. And when somebody comes up to me, they often seem to know me, but I don't know them. Because I'm one and they're 600. And it could be an old student, it could be a colleague, and often needs some help with this. Another time this happens is when I go to conferences. There's people, I often email them and so on, but I only see them once every 2 years. And it's hard to know if you're dealing with the right person. You have to go up and read the name tag of people you know to see if it's the right person. Because I've started a conversation with somebody thinking it was person X, and it turns out it was somebody who doesn't speak any English. And then you sort of have to try to back away. So we did this at the International Conference on Biometrics, a very, very good conference last year, and I was general chair. And we did some articles on this showing how we could recognise people at the conference. And what was cool about this is we had people upload their faces before they arrived at the conference. So there wasn't an enrolment session. People enrolled themselves and actually through their mobile phones. They got the app, they took a photo of themselves, and then that photo was shared amongst all the colleagues. So you only had to take your own photo. You didn't have to take everyone else's photo because all those photos were shared. So that was a really nice way of doing things. And we had to work out this very difficult problem of distributed do-it-yourself enrolment, rather than having go to the passport office or the campus pharmacy and get your face taken. You did it on your own phone. So why conferences? I run lots of conferences, and I'm interested in the problem of getting rid of the name tags and other aspects. And I have some trouble recognising friends at conferences because I see them very rarely. So it's effectively gives me prosopagnosia because I don't recognise people I should know. I wanted to give something back to the scientific community. And we had to solve this problem of DIY mobile distributed face enrolment. So that means that people could enroll themselves under any situation just using their mobile phone, and then that face would be propagated to everybody going to that conference. So you could recognise them and they could recognise you. We had to address consent and privacy issues. There's a lot of laws about that. So, when people added their faith, they had to sign off a document to say, it was permissible to do X, Y, and Z with these things, and we're going to delete the database after a period of time. So it's a bit like prosopagnosia, but it applies for normal people. It's a situation where you'd like to know everybody because you're going to a conference, you all have the same interests, but you don't know who you're talking to. Okay, so this is an example. We actually did this on augmented reality glasses, and this guy's got these glasses. He's recognizing me, and this was at the welcome reception. What was really interesting is how the interactions worked, because people would go up to complete strangers to see if they could recognize them. And they'd say, "Are you in the database?" And people would say, "No," and they'd walk away. And if it was in the database, say, "Oh, yeah, so you're from the University of Baghdad. Oh, that's cool," and start this conversation. So it was really, really good icebreaker at the welcome ceremony, because everybody didn't want to talk to people they knew, they wanted to talk to people they didn't know. So this is sort of funny, because this guy's Joseph Kittler. from University of Surrey, who's a top person in biometrics worldwide. And this guy is the #1 cited computer science author, who's also a top guy in biometrics, and they were at the conference, so we had really, really good attendees. And we did something in the newsletter and talked about it using, very world first as far as we knew for doing this. And we also made a version for the UQ Open Day, and these are some photos. This was to sort of recognise people who went to the Open Day, and it was a similar process, but I was very proud of this recognition, which worked absolutely perfectly, because that sort of skin colour is quite a challenge for a number of reasons. And you might have heard stories from the US where the face recognition just doesn't work on African Americans. So this guy was from Sudan, and I'd say he's darker than most African Americans, and it just worked perfectly. So that was a good hit. We did this at the Magnified World Conference, and this is Barry who came out. So we demonstrated the app.
Is to know about you just from your face. Well, facial recognition technology is already here.
And while it can be really useful, there are, of course, real concerns about how it might be misused. Today's Christina Hearn investigates.
Instantly, a person can be recognised and identified just by their face.
You're going to be able to meet people and immediately know who they are.
Forget introductions at a party. Now your mobile phone will be able to tell you exactly who everyone is.
Oh, hey, Trevor.
Have we met?
Lucky I had that.
Here at the Magnify World Conference in Melbourne, attendees have all downloaded a facial recognition app. Your phone is then able to do the work for you.
Rather than having to read or scan name tags, you just hold your phone up and it immediately recognises the person that's in front of you. Most of this stuff has been kind of out of reach, but to have it in a simple smartphone app is pretty advanced right now.
Barry Sandra developed the app with the help of the Queensland Brain Institute because he suffers from prosopagnosia, or face blindness.
If I leave you and see you out of context in a supermarket somewhere or at a cocktail party, I would walk right by you and you would say, what an arrogant SOB that guy is.
But this phone scan is just the start.
It is very Hollywood.
I'll be back.
Experts predict that soon we'll be walking around in glasses which will scan a room and tell us who is who.
Instead of looking at your phone to get that extra information, having it there in your glasses, and I wear them anyway, an extra little layer, possibly with a voice in the ear to speak to me as well. I think that's coming, and we're going to be very happy using it in a few years' time.
Because you're going to be able to meet people and immediately know who they are.
But it also takes away a bit of the human element of going up and saying, hi Barry, I'm Christine.
Oh, quite the contrary. It actually brings the human element to every person. It's an empowering thing for everyone.
While this technology has its obvious benefits, like security at our airports, it's now also having a much broader reach. Some of our private schools are trying.
So that was an augmented reality conference, and we've done quite a bit of recognition from glasses, from phones and so on, which is an augmented reality app. This is sort of commercial video, but it's pretty cool. Has anyone seen Black Panther? Yeah, this was after Amazon failed dismally at recognising black people, so the people I was working with decided to use Black Panther characters as their main characters to sort of emphasise the accuracy on African Americans.
To databases is simple and can be made inclusive to our customers, or by adding our own hardware to a legacy format with some customization. By adding tags and specific information, the newly added image is ready to use instantly. Adding mobile face detection with the same level of accuracy as our network systems, be it standalone or as part of a fully integrated network, is also very simple. Having data fed directly to a mobile user within their glasses is a new and innovative solution. Galahad Mobile is a next-level platform in face detection and matching for tomorrow's world. Simple synchronization and quick with an existing database is achieved with a simple click in the menu. Galahad Mobile gives you access to over 1,000 images on a mobile database, and subject to licensing, this can be increased. No restrictions on race or colour. The system is well practiced on all shapes and forms and is prepared for difficult and awkward lighting conditions. Adding new faces onto the mobile device on the fly is just as easy, and will sync with the main database if networked. This gives instant recognition to all other mobile users and control room users and provides notifications to authorised personnel. Custom tags create simple, inclusive alerts to listed persons and authorised personnel. We include simple colour coding of information for fast response.
And this is an example from another augmented reality vendor, and they were showing the social recall app for phones, but using them on AR glasses. Okay, so I wasn't going to talk about security, but I sort of like that area. Yeah. Anyway, let's look at some completely different uses for these technologies. And this one really excites me. It's using face matching to detect genetic disorders. This is a really strange one that seems to work. We've got some nice publications there. So these children have genetic disorders, and in less PC times, they sometimes just called funny-looking kids because they sort of look a little bit strange, but you can't say why. So you know how if you've got Down syndrome, which is a extra chromosome, they have a certain look to them. And this turns out to be true for a lot of other genetic disorders. And there's something like 7,000 identified genetic disorders. So it's actually, if you see somebody who looks a little bit strange, you think, is it just because they look strange, or is it actually a genetic disorder? So that's the question. And so almost all genetic disorders are associated with severe mental retardation. Because I said, well, what does it matter if somebody's got a genetic disorder? You know, they said, well, basically they can't speak. They have very bad prognosis. And so it's really important to know that for care and treatment. Also to give what's called reproductive confidence to the parents. Because if they have a child that's got a genetic disorder and is never going to speak and, you know, going to be a tremendous burden, can they have another child? Because typically women, once they start having children, they usually have a few together. But do they know if they're going to get a second child like that? And if you know what the disorder is, you can actually say, yes, this is not going to happen, or yes, it is going to happen. But parents can't get those answers. So until they get a diagnosis. And we developed a system, and we used face recognition as a means to supplement the doctor. And it turned out that it was actually more accurate than a geneticist with 30 years experience. But what was even better is where it got the answer wrong, the geneticist tended to get it right. So if you added the software plus a geneticist, the accuracy doubled in terms of diagnosis. And that was a really good outcome. So this is the FaceMatch website for parents and doctors for collecting these faces, and some of the team with Hunter New England Health. And this is my collaborator, geneticist Tracy Dudding. And she'll say a few words.
I'm Dr. Tracy Dudding-Blythe, lead researcher of the FaceMatch Project, which uses state-of-the-art computer face matching technology to match the faces of children with undiagnosed intellectual disability. Despite recent advances in genetic testing, the majority of children with moderate to severe intellectual disability do not receive a diagnosis. Parents describe the diagnostic odyssey, spending years searching for an answer. Up to 50% of these children will have facial features which can provide a clue to diagnosis. By matching the faces of children around the world, we hope to help families find a diagnosis earlier and to potentially discover new genes important in brain development. Participation in this project can be initiated by a parent or a doctor. Parents will be asked to nominate a clinical geneticist or medical specialist to help the FaceMatch team work with the family and their doctor. Parents of children with known genetic conditions will also be invited to participate. More information about the project, including privacy, security and confidentiality, is provided on the website. Please contact us if you have any questions or difficulty registering. We are very grateful that you are considering participation in the FaceMatch project. We would also like to thank the Newcastle Permanent Charitable Foundation, Hunter New England Health Service, John Hunter Children's Hospital, and the Hunter Medical Research Institute.
And back to health, I just added this today because this came to me yesterday. I've got a visitor, Kasturi, coming from University of South Florida, and he's going to give a talk. And I said, have you got something you want to talk on so I can schedule the talk in September? And he said, yes, this is our latest paper, and the paper is on measuring pain for neonates. So the neonate is a newborn baby, or actually, neonates are usually preemie babies. And the trouble is they can't tell you when they're in pain, so how do you know that they're experiencing pain? And this is quite difficult because they can't tell you, ouch, that really hurts. They're a tiny baby. And this is a project which I might be collaborating with the University of Southern Florida. And so this is automatic pain assessment from facial expression using of course, convolutional neural network. So there's a neonate, and that's Kasturi. And I said, hey, that's really cool. My wife's been a specialist neonatal intensive care nurse since 1985. And she's working in all the NICU units. So straight away I said, hey, look at this paper. It's right in your area. So, and that's using facial expression, which is part of the, I suppose, facial research. We've also done work on animal face recognition. So we did work on dingoes with National Parks and Wildlife. And it turns out you can actually get pretty good dog recognition or dingo recognition from photographs. Not too different from a human. So we had a lot of data, animals there. We got 70% of the animals recognised rank 1, 78 were recognised in the top 10. And so at the time we're thinking of having some sort of media app, some social media app type thing for dog recognition or dingo recognition on Fraser Island, because they would put these tags on the dog, and it's very debilitating to the dog. It's a big heavy tag, it gets ripped off and they get their ears damaged and so on. And so the group who were trying to protect the dingoes wanted some less invasive way to identify the animals and rogue animals. And of course in Australia the dingo story is quite famous. And so these are our friends, but as you know, they're fairly dangerous animals, so probably sticking a mobile phone in front of them is not such a great idea. But you can recognise them. So you could passively do identification, time, location information, which could be collected on a server. So currently, if they want to identify the dogs, they have to tranquilise them, which is very bad, and then they're basically knocked out, and they put a tag in their ear, and some of them die from that. So it's pretty invasive. So facing the future, there's no turning back. Okay, face recognition is here now, and it's going to become more and more pervasive. So the question is, how do we make it a better world, not a worse world, of course. It's now accurate, convenient, and relatively cheap. So our face is really important because it radiates our identity to everyone around us. And it's been shown that it's the face more than anything else about a human that allows us to identify them. So when we walk into a room, everybody looks at our face and it immediately does like a login. And it's so important, like if you see somebody, you say, oh, I recognise you. I won't tell you that Irish joke that I told you last week again because I know that you already heard it. So when we see somebody, we know them, and then we decide what conversation we can have with them that's not repetitive and things. So we use this all the time ourselves. So that there's lots of biometrics, but face is really special because it's the one that humans use. Okay. So computers can now accurately register facial information in the blink of an eye. The applications are limitless. But these AI technologies are only just able to become public now and ubiquitous. So you're seeing the very, very early days of rollout. Face and voice technologies. I mean, I think I was with the National Bank the other day and they're using voice identification and so on as well, which is another one that's good for mobile phones. And face recognition is much more accurate, typically. So that's what I've been doing for probably since about 2000 in face. Okay.
Thank you very much, Brian. I'll give you a chance to grab a glass of water. This is your chance to ask questions, and I'm sure you're going to have some. So if you could write those down. There's already been a few come in on Twitter already. Write those down, wave them around over your head, and Dom and Leonie will come round and collect those. We'll get through as many as we can. In the meantime, of course, we will be back next month on August the 12th. We're not quite ready to announce the title of next month's talk, but I promise you it will be a delicious evening. So come along to that. We, of course, if you want to keep in touch with that, sign up to our mailing list or follow us on Twitter, and you can make sure that you get notified as soon as that talk and those tickets become available. Okay, wow, that's a lot of questions. All right, so maybe I'll get you to join us back on the stage, Brian, and we will go through these. Let me just flick through Twitter here. So the first question I have is from Shane on Twitter, who asks, how close are we to achieving the speedy face-in-a-crowd recognition that we see in TVs and movies?
It's much faster than that. Typically 10 to 24 million matches per second. So it's quite fast, and you can store the population of Great Britain on a USB stick.
Well, Is that being used? So we heard about it being used at the football recently, the sort of facial recognition. Like, is this widespread, rapid facial technology available yet?
No, it's not widespread. It's very hard to do from CCTV cameras, and that's sort of the holy grail. So we've been working in this area for a long time, but there's a lot of very poor systems out there, and they're getting better. But that's why it's much harder than border control.
Okay, question from Connor. So I'm going through Twitter at the moment. Question is there any truth to the rumour that Facebook was using the 10-year challenge to train their facial recognition algorithms?
I don't think so. They could. They may have used them, but I think that's just a rumour. They have lots of that stuff already. Yeah.
Well, that's comforting. Okay, we have quite a few questions here around privacy and responsible use of this technology. So the first one is, sorry, I put it down, but question around what are the, you mentioned the steps you need to take around privacy of images for the conference. What are some of these steps that have to be taken in Australia for?
It's generally, Australia doesn't have strong laws, but in Europe they've brought in the GDPR laws, the revised GDPR, which are quite strict. And some people are saying it's the death of facial recognition and surveillance systems, because you virtually have to get everybody's consent to do anything. So somebody would have to consent to facial recognition, and of course, if you're looking, the obvious application is looking for terrorists or criminals and so on. I mean, you have to get everybody. If you do that, everybody who walks past your camera has to sign a written consent form. That's not going to happen. So it makes it quite difficult. So those laws apply in Europe. They don't apply in Australia, and certainly don't apply in China. But they could apply. So it's largely based on the concept of consent. And consent's pretty easy to do when you've got a cooperative system like passport control, because do you want to go through here and have a 5-minute delay, or do you want to go through here and have a 1-hour delay to get onto your plane? And most people choose the facial recognition for convenience and speed. So it's the same in Australia. You don't have to use the facial recognition. You can go through the counters, but why the hell would you? And I mean, I think it's incredible when people are basically saying, "Oh, it's an invasion of privacy." You're going through customs with your passport. You know what I mean? Of course they have to know who you are. I mean, that's a stupid thing. But certainly in a city mall or something like that, that's a very different situation. But in border control, you don't have any privacy. Certainly if they want to examine you, you have no privacy whatsoever.
So we have a couple of questions building on that around broader government surveillance, but also merchants tracking customer behaviour, asked David on Twitter.
Yes.
What sort of frameworks do you think might be in place in the future to manage that type of use of the technology? Well,
retailers already track most of us. They do it through other technologies. Mobile phones mostly, and they look at the addresses of the mobile phones, and they know when you enter the shopping centre which shops you've been to, etc., tracking your mobile phone. So they've got that. It's not using face, but cheaper technologies. They're interested, because of the imprecision of those methods, they're interested in using face as well. And there is a pushback on that, and certainly that's the sort of thing that the GDPR laws are making very difficult, because you'd have to get consent from customers. So one thing we were looking at with a retailer was they wanted to use face recognition for women's cosmetics. And the reason, the idea was, how do you do that? Well, one thing they'd do is they'd offer 10% off if you accepted the face recognition, and if you didn't accept it, you had to pay more for everything. So you sort of had to become a member of the club, and that was a requirement. And when you walked into the shop, there'd be like a Hollywood mirror, which, you know, women would go, there's a makeup shop. Women look in the mirror, but there's actually be a camera for face recognition, and it would alert everyone there that a customer is returning. It would say what brands they like, what sort of things they have, and they'd walk inside and they'd offer you like a cappuccino and a piece of cake. And the analogy is really more like an airline lounge or a gentleman's club, where, you know, you go in there and it's home-like, and you're looked after. People know your preferences. They know what sort of cake you like. If it's carrot cake, they know if it's a cappuccino. They know the colours you like, etc., etc. So that was sort of the model there, but it's just something that where, you know, people would want to be identified, just as people are very happy to bring out their frequent flyer card to go into the Qantas lounge, because they get rewarded for it. Generally, people will give up their privacy if they're given something for it. Whereas that's the trouble with like surveillance with policing. Of course, they get nothing for it. But when you give them something like a faster processing, cappuccino, whatever else, people will generally, you know, give that away voluntarily.
Right. Getting back, and at BrisScience, anybody who wants some free food outside just needs to sign up to the app. No. Yeah. It's great. All these questions, we know who's asking them. It's fine. So we've got some slightly more technical questions now. One is getting back to this question of, you mentioned black skin tones.
Yes.
What is it about that makes it challenging for the facial recognition software? Or typically has?
It's often not so much the recognition, but the detection. And so it's really just simply lighting. It's contrast. It's you know, having enough contrast in the skin tones, and of course, with very dark skin, that's a challenge, especially if there's not much lighting, because you need a lot more light to show the facial features up. So it's just a lighting issue. And there was a case some years ago where HP released a webcam that did face detection, like tracked your head, and it only worked on white men, didn't work on black men. And so it was all over the internet, you know, racist and, you know, this sort of thing, because it doesn't work on blacks because it wasn't trained on dark faces.
Also some questions around the accuracy of modelling for twins, siblings who look alike, the doppelganger effect. What's the resolution that you can separate out closely related people? Or
the theory is that you can't tell twins apart, identical twins, and it's very hard for humans because your face is determined by a genetic code, unlike your fingerprints and your iris, which are actually chaotic. So twins have different fingerprints and they have different irises because it's not controlled by the DNA. It's basically a chaotic process during growth, and it's like wrinkles, and they all come out different. Whereas the face is determined by the genetics. But the strange thing is that two people who look the same to us often don't look quite as much the same to the computers. So we've certainly had some examples where we can tell twins apart, even we think they look the same, because they sort of, in human perception space, they look very similar, but if you actually do calipers and measure them and so on, you'll actually find there's a bit of a subtle difference between the two. Often one's, you know, like a little bit wider in the face, that sort of thing, but we don't perceive those differences. A bit like, you know, when you see a film, sometimes they stretch the film, and everyone's perfectly recognisable, but they're 30% wider. And we don't even notice it, you know? They just look a little bit fat.
Does it become more challenging to make identifications the larger your data set is, the more people you have in your data set? You're, I guess, identifying out of 100 people versus 100 million people?
That was always the theory, but you can actually get very high accuracy on quite large databases now, so it doesn't seem to degrade anywhere near as much as you'd think. Or people always thought, because that was verification's easy because you're only comparing against one person, whereas the true recognition problem is you might be comparing against 30,000 people or 200,000 people or something, but it actually works pretty well even with databases of that size.
Look, we're almost out of time. So I'm going to go with the question which just came in on Twitter 17 seconds ago. David asks, what are the best ways of breaking face recognition? Is the outstretched palm over your face the gold standard?
Paper bag's pretty good too.
All right, tips that you can take away and experiment with at home. Please join me in thanking our fantastic speaker this afternoon, Professor Brian Lovell. And please join us outside for some food and drink afterwards and lots more questions for our speaker.